Hello and welcome to the new session in data science. Today we'll learn about multiple linear regression. In our previous session we have learned what a linear regression is. Let me remind you. So if y is your dependent variable, y is equal to b naught be your coefficient plus b1 will be your coefficient for independent variable x. But today we'll increase the number of dependent variables. Let me use a capital X. Increase the number of independent variables plus b2 into x2. So your equation goes on growing like this depending on the number of independent variables that you're going to have. Let's get started with our data. So you can open any interpreter of your choice, any IDE of your choice. Today I'm going to use the IDE called Spider, which comes packaged with Anaconda. I just restarted the kernel so that everything is started from the beginning. We are going to use 50 startups data set, and I'll show you just now how the data set looks. Before doing anything, let's import our favorite modules for our data analysis. As PD, import NumPy as NP, and from matplot library we want to import pyplot as probably call it plot, and select this and execute so that you have imported the libraries. Next step, what you are going to do is we are going to read our CSV file. To read it into a variable called dataset, dataset is equal to use our favorite library pandas, read CSV, give the file name, that is 50 underscore startups dot CSV, close it, select it, and then control enter, executes it. Go to your variable explorer, double click, so you'll see that it has 50 startups over here. So basically each row represents one startup company, and these are the values. Let's say for startup 1, so index start from 0, so startup 1 spends around $1,600 on R&D, then $136,898 on administration and marketing, and the startup is located in New York City, and the profit is around 192. So you get the idea. So this data set is around 50 startups with few missing values, I guess, but that's all right because the data set looks quite clean. So look, when you look closely, you can see that the state column has, so basically state is a categorical column having around one Florida, New York, and California. So it has 3 classes, whereas these three independent variables are numeric data, so one categorical independent variable, and profit will be a dependent variable. So let's get started with our data set. As usual, we are going to save all the independent variables in X. So to do that using .iloc, and then all the rows but all the columns except the last one, .values, and y is equal to dataset .iloc, so index location, comma. So here you have only last value, right? So last column values, select it and execute. So here you can see here in your variable explorer that all your predicted or dependent variable is here in y, and all your independent variables. You cannot see your independent variable because it's of the type object. But do not worry, you use the console efficiently. So enter X. So here you have all your independent variables. So next step, what we are going to do is we have to do a bit of pre-processing, because you can see here the fourth column over here is a categorical data. So as we know that in Python, these machine learning libraries do not handle the categorical data very well. We got to pre-process it, which is quite easy from sklearn, our favorite library for machine learning. Pre-processing, import a class called label encoder. Also import a class called one-hot encoder, because we also got to do one-hot encoding on the data since there are 3 classes. So first we'll initialize an object of label encoder, and that is equal to label encoder. Control I will give you, or you can inspect this particular class using Control I. So let's keep it as it is. We don't have to input any of the parameters right now, and use the variable or the column. So index starts from 0, so the third column, give it label encoder dot fit transform. That's the function you got to use. And inside the fit transform, again you are going to pass the values X, all the rows, and the third column. Once that is done, select this and execute. We'll check our values now in our okay. Still you cannot check it over here because it is an object, but here you can see your all your categorical values are changed into 0, 1, 0, 1, 0, 1, 2, 3 and things like that. So let's do the one-hot encoding now. So to do that, one-hot encoder equals one-hot encoder and pass categorical features, the third feature, that is what you want to pass. But you also got to remember that it should be a list. Once that is done, you can directly pass, you can call the function called fit transform again and pass X, but don't forget to convert it to array. Select it and execute. Now your type is changed to float and you can easily visualize it. So here is your one-hot encoder data, but there is something called as dummy variable trap. So instead of all this using all the 3 dummy variables, what you're going to do is you're going to eliminate one of the variables and pick the remaining. So you're going to leave out or select all the rows but leave out the first column and pick all the remaining columns. So this is to eliminate the dummy variable trap. You can see that you have only 2 one-hot encoded values. What is the next step? Next step is splitting our data into test set and the training set. For this we are going to use from sklearn model selection dot model selection. Any guesses? Yes, you're right. Train and test split. X underscore train and X underscore test, Y underscore train and Y underscore test is equal to train test split. Control I will give you all the parameters that you can pass. So test size, train size and things like that. So for our values, X will pass X and Y, followed by test size. Test size is equal to, let's say, 0.2, and we'll set the random state so that we can reproduce the same results again and again, is equal to 0. So if you want to get the same result as the result that I'm getting, please use this random state value and set it to 0. So now select these and execute. Once that is done, go to your variable explorer and check whether things are working fine. So your test data is over here, which has 10 values, and your train data, which is here, almost 40 values. So it has split into 80-20 data set. Next is what we are waiting for, multiple linear regression. For this, we are going to import sklearn linear model, import the same linear regression which we used for simple linear regression, initialize a variable regressor is equal to linear regression, and control I to check what are the variables to be passed. For this, we are going to leave everything as is, and then regressor dot fit x train and y train. Select and execute. So now our model is trained on the training data. Next step is to get this predicted values. Y predict is equal to regressor dot predict and pass x underscore test data. Execute. Go to your variable explorer, open your predict and open your test data. So if you match this, they are quite close. 103, 103, 132. This one is quite far. The third value is also far, but the fourth value is quite close by. The predicted value, this on your left is a predicted value, on your right is the actual value. And also you can find the accuracy score using regressor dot score and pass x test as well as y underscore test. Select it and execute. So your model is giving you accuracy of 93.47%, which is quite good. So in further tutorials, we'll learn about how to optimize this further. So that's all for today, guys. I will share this code. I'll put it in GitHub so that you can access the code and copy it. But I suggest you writing the code by yourself so that you get hands-on experience with this. And if there is anything else that you have a doubt in, please leave it in the comments below. So thank you for watching. Bye.